the standard brake, rear brake on an FZR is quite a lump, obviously designed for those road riders who only use the rear brake. Anyway, it's pretty horrible. I mean, the caliper's not bad, but it's just heavy and you know, it's just horrible basically. The rear disc is also pretty big and solid. Now this one I've actually skimmed off a bit on the outside edge. It was pretty badly mangled up. Someone had run the pads right down to the bare metal and scored the disc up pretty good. So while I was taking that material off the outside edge, I also took a skim off here, which was a little problematic because, as anyone will know that's ever machined this sort of a thing, they ring and you get horrible patterns around it. So anyway, I tried various speeds and feed rates and all sort of stuff, and got a pretty good finish, and then just used a bit of emery tape just to polish it down. So it came out pretty good, I reckon. Certainly much better than it was. Now that will be used with this caliper. So this caliper is actually designed for a 200mm disc. This one was 210, I think it was. So this little caliper will fit on here. Quite nicely, but I need a method of mounting it on there to the axle. Now the aluminium bracket to mount this, as you can imagine, is similar to this. Big, heavy, totally unnecessary for just using this. The thing is, I don't even use the back brake when I'm racing. So when I tested the back brake on the bike that I ride, my twin, actually the pedal felt good, but in actual fact there was a problem, and it didn't make any braking effort at all, like absolutely none. You could still spin the back wheel freely, even with this caliper on, and really standing on the pedal, it just didn't make any difference. So I didn't even know. So anyway, gonna mount this. I've got a new bracket design sort of drawn up. What you can't see is there is center marks popped in it where the bolt holes are going to be, and where the boss will be in the middle. And I have scribed the lines where where it needs to be cut, and it's not just black felt tip, which you can see in this here. And borrowed Kev's power saw and just roughed it out. So there'll be a boss goes inside here on the axle, and then this will be what I intend to do is make it so the caliper mounts up. This will slide onto the boss, and when I've got it exactly in the position I want, we'll just put some welds on it, and just to hold it in position. There'll be a stay arm goes from here forward onto the swing arm, just like it does on the standard brake caliper mounting setup. So that's about it. Time to get this in the mill and start making some cuts. Alright, I got the piece clamped on the mill. The first step, and I've already clocked it up on this edge. I didn't really need to, but I have anyway, just because it's good practice. So it's less than 0.01 run out according to the indicator. So the reason for that is for this portion here, I need to go, well, I don't need to, but I'm gonna go down, leaving, so there's only a 5mm thickness left on the bottom here. So there is a little step here from previous machining I've done. So it's about 4 or 5mm to take off this down to here. Now, could do it in one step with a big cutter. Got a 20, I do have a 20mm carbide cutter there, pretty nice piece, but it's not ideal. So what I'm going to use is this cutter. Now the reason I'm using this is it is an 8mm diameter and the radius is 1. So the radius it's talking about is on the end here. It's not a sharp point, it's got a little radius. Now the benefit of that is once I get this step machined in, where it goes in and then transitions to the vertical bit, we'll have a 1 millimeter radius left in it, so there'll be a nice little curve. Just a better way of doing things. So let's get it set up in the chuck and make some swarf. So I've finished machining the 5mm depth off this for the width that I wanted, and I don't know that you can actually see it, but there's a little radius in the bottom corner along here and also on the end here, so hopefully that'll reduce the stress raises. Now I had marked on here, on the surface I've machined off, where the holes were going to go. Now what I've done, I did record the X and Y coordinates of these holes in relation to the center of this hole, which I haven't machined off. So I have zeroed the table with the center underneath the tool, zeroed the X and Y. Now it's just a matter of transitioning the table back and across to get one location, and then just simply translate 64mm to get the other one. So easy peasy. Let's see how it goes. Alright, so I have drilled a 15mm hole in the bracket which matches the axle, so I can then fit it up, make sure the centers are all correct. Now when I did that, the caliper just dragged on the disc. Now a couple of fixes, but I could machine the disc down a little bit more, no big deal. Or since I'm working on the mounting bracket, I can just offset bore the hole for the mount, you know, where it goes on the axle, 1mm. So that'll give us a clearance here. Now I've also offset at 0.3 the hole so that the caliper is actually rotated ever so slightly, and that'll square it up on the disc as well. So no big deal there. So that was all fairly straightforward to do. So I've got it set up with the offset in that direction so that the hole is further in that direction, and you can just see here I've just touched it down and you can see how it started cutting on this face here, or that side rather than this side. So yeah, it's pretty obvious what the situation is. Let's just do a cut. So the turning the mill on and off is actually quite nice. With this VFD you can set the speed as you like, apart from being able to switch to high and low speed using the switch as normal, and you can see how this ramps up nicely rather than a sudden start, which it would have done with the old on off switch. But yeah, it makes get that out of the way. Also cut a thread, that's just as I pointed out. You might be able to see the different finish though. It hasn't actually bored anything out on this side. But this side here you can see it. So I'm going to take this out to about 30 millimeters, which is the diameter of the spacer I want sitting on the axle, and then this will just slip onto that and then be welded, as I said earlier. Alright, good progress being made. The bracket, I bored this hole out to 30 millimeters in here, and then I machined up this spacer that's also 30 mil OD. It's ended up a little slip fit. It's actually difficult to get in, but once it's in, you can slide this plate back and forth. Now, in behind here is the a spacer. It's not the original one, but it's the exact same size. So with that and this in place, as you can see, it's not binding on anything. I can still slide the caliper back and forth on the disc to get the body of the caliper centralized on the disc. So what I've got to do is just get that in place, and then I'm going to weld this so that it's held in place. Being a double act 2-piston caliper, it can get pushed. If one piston gets a bit sticky, it can get pushed across, and the braking would still be okay, but not ideal. This plate needs to hold the caliper centralized on the disc, so quite happy how it's coming out. I'm hoping to borrow a rotary table so I can do a relief in here with curves rather than just taking a chunk out of the middle. It'll just look a whole lot better, and I'll be a lot happier with it. This bit here is for the brake stay arm to connect to. So far looking pretty good. Well, the good thing is my friend said I could borrow this, so I shot down to his work and picked it up this morning. Now you got to get it all set up ready to use, so that's what I've just spent an hour or so doing, maybe more if I'm honest. So first off, clock this hole up so that it is central on this table. So there is a little bit of run out. It's not that big a deal, because all I'm going to do is make cuts basically where the black is. That's more or less the area that I want to remove. It's going to leave 10 millimeters each side and at the bottom, although with the boss in there will be some welding around that area, but it's not a big deal. And it's 10 mil. This line you can see here, hopefully you can see, is effectively this side. It's the mirror image. I will relieve an amount off where this side is extended out to go to the brake stay. So anyway, got it clocked up on this, and then I have moved it 29 millimeters. Actually, the whole table's gone 29 millimeters this way, which means the center is now 4 millimeters inside this line. So this line is 25 millimeters from the center of this, and another 4 millimeters. Now what I intend to do is use a 8 millimeter cutter to make passes back and forth here till I go right through. So I've got it mounted on top of another plate of aluminium, so I don't go making a cut in the surface of the rotary table, which would not be good. So I'm going to do that, and then I'm going to extend it out to this other end, and I've got the calculation, the number written down somewhere. I'll make passes back and forth as well. So that'll leave the ends somewhere close to this line. Now I could get all scientific and figure it out, but there's really no need. The distance from there to there is what I'm after, and I'll stop it right next to that line. Note on here what the angle is where it stops, and I'll just go back and forth between the 2 points until I've gone right through. And then what I'll do is I'll clock up on this hole, or the end of the slot. There'll be a slot here, and the end of the slot at this end, and then I'll just join them together, easy peasy. And then go to the other side and I'll rotate it around a bit so that this line is lined up on the x-axis. Line up the holes, clock it up as I just said, and then do the same on that side, and then the centerpiece should just pop out. That's the theory. So anyway, it's pretty much ready to put a cutter into it and start making some swarf. But I think as a precaution, I might give my mate a call about what I'm planning and just see what he says. He normally has good ideas, so I'll try that. I'll check with him first and then get into it. Right, on to it. All right, there was no problems at all cutting these two curved, these arcs. They are centered on the center of this hole here, which means they don't meet the sides here at 90 degrees, because those lines are not centered on this, they're centered on a point somewhere south of here. So now I need to make the cuts through these two areas here to remove this centerpiece, and I have decided that it's going to be easier to do that if I just simply remove this from the rotary table, take the rotary table off the mill and just clamp this down with one end centered on there, put an 8mm bit in there, and then just put an edge against them, and then clock it up in x-axis and just make a cut. And I'll have to repeat the process on the other side. Could do some maths, you know, angles and displacements and do it all, but it's actually probably going to be quicker for me anyway to simply take this out and clamp it down and do exactly what I just said. All right, the question came up, how am I going to get the cuts between the two curved grooves lined up exactly with the end of the milled slots? So what I come up with is putting a plate clamped down on the mill, drilling and using an end mill to make exact right size two holes, exactly the distance apart of the two grooves, putting a carbide cutter on one, got the one all lined up here, push the part I want to machine hard up against the cutters, and then clamping it down. So if I can get this out. So what I've got now is, because I made these two holes just by simply transitioning the x-axis, so those two holes are exactly in line with the x-axis, exactly in line. And then this plate, the end of these two grooves are exactly lined up on the cutters that were in the holes. So now it's just a matter of going back and forth between the holes. I know the exact distance between centers. It's 22 millimeters from there to there. So I just got to go back and forth 22 mil. And then what I'll do is I'll put the cutter back in, unclamp it, flip it over, and line up these other two holes, do exactly the same thing, at which point the centerpiece will fall out and the edges should be perfectly lined up here, because they are on the cutters. And when this is flipped over, this side here will be lined up on the same piece. So the the base plate is clamped in using its own clamps, and then this piece I'm making is clamped on top, so I can take this off, flip it around without disturbing the base, so I know it'll line up exactly right again. Let's give it a shot. Pretty much done. Just needs the boss welded into the center and it'll be ready to go. It's turned out nice and light, which is what I wanted, and yeah, it should do the job pretty well, I think, looking at it. Anyway, let's hope. Might give it a test this weekend by the looks of it, although I've already got a pretty good caliper on the bike, so I might just leave it. It turns out to be 88 grams. Not too bad, according to my drug dealer scales anyway. Well, pretty happy with the weight reduction, less than 600 grams for the new one and a bit over 1200 for the old caliper and bracket. Well, I've finished the little bracket. I mounted up the caliper, fitted it to the wheel. Seems to all work pretty good. I do need to manufacture a stay arm yet, but that's a minor detail. Well, minor in the scheme of things. So got a nice brake hose with a right angle fitting, which fits on really well. Goes to the master cylinder up here, and this master cylinder was actually off the other bike, which had a completely different lever on it. So what I've had to do is cut the threaded rod out of the bottom of the cylinder, put a little threaded sleeve on it, and then put an extension threaded rod on it down here. So as usual, I didn't have the proper nuts, so I've had to machine these. These were flange nuts, so I've just machined them down. So it's all nice and tidy, and it looks like there's a bit of movement there, but it's perfectly reasonable and it works. I haven't, tried swinging on it with the wheel spinning too hard, because there's no stay arm. Although it's bolted up tight, it'll still spin the caliper if I tried anything too stupid with it. But yeah, pretty happy with how it's come out. Looks good. Like I said, just the arm to make, so that's no big deal. We'll call it quits here, I think.